engineering curriculum. Our next speaker has a Master of Science degree in the Institute of Water Education in Delft, the Netherlands, wherein he actually graduated as cum laude. He is now the PRO of PICE Cebu chapter, and currently he is the chair of the Department of Civil Engineering of the University of San Carlos. He is also the former assistant dean of the School of Engineering of the University of San Carlos, and he sits as member of the CHED Technical Committee for Civil Engineering. Ladies and gentlemen, let us all welcome Engineer Ricardo Fornis. Sir Rick.
Yes, Aure, thank you so much for that introduction. I would like to share my screen now. Okay, I believe my screen is now visible.
Yes, sir.
Okay, good afternoon, everyone. Okay, the topic that I'm going to deliver this afternoon, the Civil Engineering Curriculum of 2018. Now, just to give you a background, when the Board of Directors of PICE Cebu started planning on this webinar series, we actually cover the different specialization of civil engineering. And then I told the group that we will not forget the academic aspect, considering that we have a new curriculum. And in the new curriculum, there is an expectation that PICE should do in that civil engineering curriculum. That's why this topic is presented today. Okay, with regards to the flow of the presentation, so here we have 4 parts. The first one is the definition of a curriculum. Second, the outcomes-based education. Then the curriculum and International Engineering Alliance. And then the role of PICE in the new curriculum. So these are the things that I would like to cover with this presentation. Okay, what is a curriculum? If you open the Merriam-Webster dictionary, the definition is so simple. It refers to the courses offered by an educational institution. And then another definition, a set of courses constituting an area of specialization. If we will stick to that definition, then we can equate curriculum to the different courses, which we actually called subjects, like strength of materials, engineering mechanics. But the right term for that is course, or those are courses. And those courses will constitute what we call a curriculum. But if you will read further educational institutions regarding definition of curriculum, then they define it differently, or maybe in a more comprehensive manner. For example, as defined by Rhode Island Department of Education, it says here curriculum is a standards-based sequence of planned experiences where students practice and achieve proficiency in content and applied learning skills. Curriculum is the central guide for all educators as to what is essential for teaching and learning, so that every student has access to rigorous academic experiences. The structure, organization, and considerations in a curriculum are created in order to enhance student learning and facilitate instruction. Curriculum must include the necessary goals, methods, materials, and assessments to effectively support instruction and learning. And in fact, this is the definition of curriculum where this presentation is anchored upon. Well, we have what we call the traditional system of education. And then there is what we call the paradigm shift of our education system here in the Philippines. If you go back in 2012 memorandum order, and it's numbered 37, it refers to policies, standards, and guidelines in the establishment of an outcomes-based education or OBE system in higher education institutions offering engineering programs. In fact, when we talk of outcomes-based education here in the Philippines, it's the engineering who is actually uh, in advanced state compared to other disciplines. No? So in accordance with the pertinent provision of Republic Act RA number 7722, otherwise known as the Higher Education Act of 1994, by virtue of resolution number 198-2012 of the Commission in Bank dated 25-2012, for the purpose of transforming engineering education into an outcomes-based system to meet the demands of the global equivalency of quality standards in engineering programs, as well as to promote continuous quality improvement in higher education institution or HEIs offering said programs. Now, you will realize later on that it is actually our aim to enter into an international engineering alliance, which we call as the Washington Accord, that somehow uh, lead us to shift the system from the input-based type to the outcomes-based system. And I will explain later on what is OBE or outcomes-based education. In section 3 of the same CHED memorandum, uh, it says here that the general standards on OBE system implementation shall be continuously aligned with the accreditation criteria set by the PTC, where PTC is the Philippine Technological Council, CASI, as well as any additional general criteria that shall be set by the Commission. Now, the criteria of PTC, there are actually 9 areas. The first one is the program educational objectives, which I will also explain later. Then we have the student outcomes, then students, number 4, faculty and staff, curriculum, program facilities and learning environment, leadership and institutional support. The number 8, extension service, community-oriented programs, and industry academe linkage. And you notice I underlined number 8 because that's an important criterion where we can collaborate, the PICE and even the industry can collaborate with this higher educational institute. And number 9, it's about continuous quality improvement. Now let me touch or let me now discuss outcomes-based education, or we call it OBE. And when we talk of OBE, the main concept is that OBE is student-centered learning. That's one. Second is the clarity of focus. And third is the constructive alignment. Now, these 3 ingredients should be present so that you can claim that you are really doing the outcomes-based education. For the different aspects, let me borrow the discussion provided by the chair of civil engineering of the University of Santo Tomas. So I actually used some of his slides during his presentation in the ASE 2020 International Conference. Now, when we say student-centered learning, the emphasis is on students learning instead on instructors teaching. In the traditional system, which most of us, if not all, are product of that system, the main actor is the teacher. Kanang style na to nga nara ka tumoy sa akong ballpen dong. So that's the traditional system. But nowadays, the emphasis is more on the students learning. It's student-centered learning. The teacher will now become as the learning facilitator. The instructor or the teacher nowadays cannot claim that he's the only source of knowledge. The teacher does not monopolize knowledge, especially now that we have several sources of knowledge. So as a teacher, you will just facilitate of what to learn in such a way that you can achieve the outcome which is targeted by the course assigned to you. Again, the students should be the main actor, and we make sure that the students achieve the outcome targeted by the course handled by the teacher. Then there's also flexibility in learning, which in fact nowadays, because of the pandemic, we are doing online. And if we deliver the traditional way of doing things, then online could be a very difficult undertaking. But because we are now doing the OBA system, where it offers some flexibility in learning, so it was not very difficult for us to adapt the online teaching and learning. So that's about student-centeredness. Another is the clarity of focus. Why clarity of focus? Because it is outcomes-based. We don't start from behind, but rather we start from the goal. We start from the outcomes. What are the outcomes that you declare to be achieved by the students as an institution? Though, however, you are not just also free to declare any outcome you like, because CHED, PTC have already standard set of outcomes. And these outcomes will focus not just on a particular part of student, but rather it will address knowledge, skills, and attitudes. The key is A. No? So the different outcomes which will be targeted as we deliver the program will address knowledge, skills, and attitudes. The soft skills, not just the hard skills. So when we say clarity of focus, then the outcome should be clear. And it should be smart and comparable to other institutions, not just in the Philippines, but even outside the Philippines, because we want to enter into an international engineering alliance. Okay, so the instructor, as already mentioned, will ensure that the students learning to achieve the outcomes. Then the constructive alignment. Okay, what do we mean by constructive alignment? First, the institution must declare what we call program educational objectives. What is this? When we talk of program educational objectives or PEOs, these are broad statements that will declare what kind of students you can produce 3 to 5 years after graduation. Take note, it's 3 to 5 years after graduation. That is during the careers of the students who graduated from your institution. Recognizing that these students are not already in the school, it's already in the different industries, it's already in the different companies. So the establishment of the PEO cannot be achieved if you don't have a strong link with the industry who hire your graduates, or to those companies who are absorbing the graduates. And they have also to help the institution evaluate whether the PEOs are achieved by the students. After the PEO, the student program outcomes must be aligned. As mentioned earlier, this, the set of student outcomes are already established by the Washington Accord, and it was adopted, of course, with modification by CHED, and it is also adopted by the Philippine Technological Council. Then it is passed on to the different universities, colleges, and institutions. Then the institutions will also uh, adapt it, and probably they will add something on it, or they are not allowed to remove something from those established outcomes. We consider it as the minimum set of student outcomes. Then the course intended learnings and the teaching learning activities will follow depending on the student program outcomes, which I will also elaborate later. I'll give you an example of a program educational objectives. And this is how we declare as the University of San Carlos School of Engineering, Department of Civil Engineering. We declare only 3 program educational objectives. And take note, these are aligned also to the USA mission vision. So 3 to 5 years after graduation, the Carolinian Civil Engineering graduate is PEO number 1, a productive professional exhibiting competence, leadership, and lifelong learning in the practice of civil engineering. Now, if you just stop there, it's difficult to measure it. It's difficult to measure the achievement of that PEO. So we will break that into what we call performance indicators. And what are these indicators? Say 1.1 meets employers' expectation with respect to professional engineering skills, including critical thinking, problem solving, and communication. So obviously, we will be asking those who hire the graduates whether these are evident to the students in their companies. No? 1.2 takes initiative, demonstrates innovation, and strives for excellence in delivering outputs or in providing services. Exercises leadership and management skills to help promote productivity and achievements of organizational goals. Point 4 adapts to change and continuously seeks out opportunities for improving self personally and professionally. You see, all these performance indicators are observable. So we will capture that in the different rubrics so that we can also rate whether the students are really achieving those declared program educational objectives. The second objective is a global citizen who is noble in character and community-oriented. So 2.1 upholds professional ethics and responsible engineering practice to ensure safety, health, and welfare of clients and the general public. 2.2 take full accountability for assigned tasks and promotes teamwork in a multidisciplinary and multicultural work environment. The number three, PO number three, a civil engineer with an emerging expertise in a specialized practice of civil engineering in various civil works, including design, construction, retrofitting, maintenance of structures, water supply, and drainage, land development, and transportation. So these are examples of program educational objectives, no, which you can assess 3 to 5 years after graduation. Then the different program outcomes. This is what I told you. It's already given by the Washington Accord and adopted with modification by the CHED and also the Philippine Technological Council. There are 12 of them, but institutions, as what I've said, can add. Say if we consider letter A, apply knowledge of mathematics and science to solve complex, so take note of the term complex, civil engineering problems. This one belongs to knowledge. Okay? Apply knowledge of mathematics. Letter B, design and conduct experiments, as well as to analyze and interpret data. When we say design, we need to produce something. So that belongs to skills. Design a system component or process to meet desired needs with realistic constraints in accordance with standards. Again, we have to produce something. You cannot do design if you don't have the necessary skills. And letter D, function in a multidisciplinary and multicultural teams. This has something to do with the soft skill. So this is now related to the attitude of the graduate. Letter E, identify, formulate, and solve complex civil engineering problems. Now, I would like to emphasize in letter A, there is a mention of complex civil engineering problems. In letter E, there's also a mention of complex engineering problems. Then letter F, that refers to the attitude, understanding of the professional and ethical responsibility. The other outcomes, communicate effectively civil engineering activities with the engineering community and with the society at large. Well, it says here that communication is a vital aspect of engineering. So we cannot say, because I cannot communicate, I will take engineering. That is not acceptable nowadays, because we also emphasize that as a graduate of an engineering program, you should be able to communicate, and not just communicate in an ordinary sense, but communicate effectively. Civil engineering activities. Letter H, you have to understand the impact of civil engineering solutions in the global economic environment, global, economic, environmental, and societal context. You have to recognize the need for and engage in lifelong learning. So if our graduates would recognize this, then they will really embrace the CPD that we have now, because we really have to engage in lifelong learning. And we have to know contemporary issues. Letter K, we have to use techniques, skills, and modern engineering tools necessary for civil engineering practice. Know and understand engineering and management principles as a member and leader of a team, and to manage projects in a multidisciplinary environment. So understand at least one specialized field of civil engineering practice. Now, these statements were actually copied from CHED, but some of, these outcomes have been improved by the Philippine Technological Council. Okay, so now that we have outcomes, we say clarity of focus. How do we address those outcomes? If we are going to assign courses that will target those outcomes, because we have several courses, we have several subjects. Now, If the outcome says apply knowledge of mathematics, natural science, engineering fundamentals, engineering specialization to the solution of complex engineering problems, you cannot say that calculus is considered demonstrative. No, a student cannot demonstrate this particular outcome in a calculus course, but the calculus course can enhance to the achievement of this outcome. So the higher mathematics, for example, if you declare numerical solutions to CA as demonstrative, then you have to design the course that this outcome will be addressed. Then that will now tell the instructor what are the activities that I have to put in place in the course so that I could see the applications of mathematics in solving complex engineering problems. You cannot just give a problem that you copied from the book, because probably that is not complex and it is not an application to civil engineering. So you have to design your activity such that you can capture the declared outcome that the students is able to apply knowledge of mathematics, natural science, and engineering fundamentals in solving that particular problem. You cannot declare all courses there. No, you have to be selective because again, the activities will follow. So CE research, for example, that can be declared as demonstrative for outcome A. Why? Because in research, the students are requested to explain the theoretical framework. And then the theoretical framework will tell what kind of mathematics is used so that they can achieve the research. They will clarify what are the natural science and engineering fundamentals so that they can perform the research. Letter B can also be declared as demonstrative under B because in B it says here, conduct investigation of complex engineering problems. Now, the Washington Accord is actually giving us attributes of what would qualify as complex engineering problems. Okay, but you see research cannot be declared for letter C. It can be declared demonstrative for letter E. Again, the different courses can be declared as introductory, it can enhance, or it can be considered demonstrative. So if it is demonstrative, then that is where you collect assessment data so that you can evaluate whether the outcome is really achieved by the students. Okay, so that is just an example. And there are other examples here, like CE Research 2 declared as demonstrative for outcome B, declared as demonstrative for outcome E. Then in the civil engineering curriculum nowadays, in the new civil engineering curriculum, there are 15 units for specialization. And it depends on the university what kind of specialization they will focus on. Now, in that 15 units of specialization, at least 2 can be declared as demonstrative for outcome A and demonstrative also for outcome C. And I would like to pose this to everybody who is attending this webinar because this is about on-the-job training. Now, on-the-job training can be used to declare attainment of complex activities. But right now, we haven't done that yet. No, the different universities has still difficulty considering this as a declarative or as a demonstrative course because when it is demonstrative, then it should be agreed upon by the partner industries that the activities that we will be giving to the students would really address the different outcomes that we need to declare under this particular course. So This one requires further discussion. And again, it can be done only if there is a strong link, if there is a strong partnership between industry and academe, and PICE will play a very important role in that regard. Okay, let me now tell you about the curriculum and then the International Engineering Alliance. The curriculum 2018 will actually differentiate the engineer from the technologist from the technician. Sad to say, in the past, in the Philippine education, many universities would declare that they are offering civil engineering. But based on the evaluation of external evaluators, most of the schools are not really offering engineering, but offering only technologist. Now, what will differentiate an engineer from a technologist? I got this from the book, A Body of Knowledge of the American Society of Civil Engineers. They differentiated an engineer from a technologist from a technician. Now, let me bring your attention to this CA professional or civil engineer. It says here, comprehends and applies advanced knowledge of engineering principles in the solution of complex problems. The complex problem will differentiate engineers from the technologist. The CA technologist also comprehends and applies knowledge of engineering principles typically embodied in a widely accepted and applied procedures, processes, systems, or methodologies to the solution of broadly defined problems. Meaning, if somebody will just be doing the repetitive work uh, of doing things, then he cannot be considered an engineer. He belongs to the category of technologist. The CA technician, on the other hand, comprehends and applies knowledge embodied in standardized. So mga standards na ang basihan, and he's more on the practice, no? Standardized practices to the solution of well-defined problems. The CA technician is more on the application aspect. I tried to construct a diagram, no, just to differentiate between the three. So this circle belongs to the technician. And the next one is the technologist. And the last one is the engineer. Notice that there is a intersection, no? There is a common knowledge or common competencies of technician and technologist. There is even a common competency of an engineer and the technician. Because for the engineer who will be solving complex problems or who will be doing design cannot make a good design if there is no input from the person who will be using or who will be implementing the design. Okay. The technologist can also perform things that the engineer can do, but the engineer is higher than the technologist because the engineer can already entertain complex problems. So if, for example, if there are matters not uh, not clarified in the code of practice anymore, then the engineer can make decisions because that's considered complex already. It cannot be considered complex if it's already embodied in codes because it's just a matter of applying the codes. Now, with regards to the competency of engineer, the International Engineering Alliance responsible for recognition is the Washington Accord. The technologist is for the Sydney Accord. And for technician, it is the Dublin Accord. Okay, so for engineer, Washington Accord, technologist, the Sydney Accord, technician, Dublin Accord. Now, if you are recognized by the different accords, meaning if you are an engineer, a graduate of the Philippines, then your degree is also recognized in the member countries of this Washington Accord, which I will also explain later. What are the attributes of complex engineering problems? Look at this. Now, these are the attributes. Cannot be resolved without in-depth engineering knowledge. Involve wide-ranging or conflicting technical, engineering, and other issues. Letter C, have no obvious solution and require abstract thinking and originality in analysis to formulate suitable models. Involve infrequently encountered issues. Then outside problems encompassed by standards and codes of practice for professional engineering. Involve diverse groups of stakeholders with widely varying needs. And lastly, high-level problems, including many component parts of sub-problems. So this is the attributes of complex engineering problem as given by the International Engineering Alliance. Okay, the new CE curriculum is provided in the CHED Memorandum Order 92, series of 2017. And again, it is outcomes-based, typology-based quality assurance. No? That is the CMO that governs the policy standards and guidelines for the Bachelor of Science in Civil Engineering program effective 2018-2019. And this is the rationale. Again, it mentioned of CMO 37, which is about the outcomes-based system of education. And these are now the different units, no, of category of courses. The new curriculum, before we have about 240, and that's delivered in 5 years. But now we have only 171 and delivered in 4 years only, no? And math, we have only 15 units. For mathematics, we start already with calculus. No more algebra, geometry, trigonometry, no more. We start with calculus. And calculus becomes only 3 units, calculus 1. Then calculus 2 is also 3 units. Other one is differential equation. And the last one, we have numerical methods. Okay. Natural and physical science. This refers to chemistry and physics, 10 units. The basic engineering sciences, 23 units. The allied courses, 6 units. The professional courses is only 49. But we have additional professional specialized courses of 15 units. So this is where you can have an in-depth knowledge of civil engineering. Then the Gen Ed courses, it's actually intended for the soft skills, the behavior of the students. Then we have the general elective and mandated. The general elective and mandated, this includes Rizal. Then on-the-job training. On-the-job training, 3 units, but other universities, they consider OJT as 1 whole semester. So instead of having 4 years, they deliver 4.5. The remaining half is for the on-the-job training. And PE is still there, no? 8 units. And PE is also in the senior high. So PE actually has gained a lot of units in the educational reform. And we have the NSTP, which is 6 units. So the total of this is 171 units and delivered in 4 years. Now, if we are going to compare the curriculum to the outcomes relationship map of the civil engineering body of knowledge of ASI. So actually, I wrote to ASI and I asked for their permission to use this in my presentation, and they give me a permit. So in the body of knowledge by the American Society of Civil Engineers, the classify the different outcomes into foundational outcome. Then we have the engineering fundamental outcome, the technical outcome, and the professional outcome. Okay, it's color-coded. So when we say foundational, uh, actually the color of this has changed now. So these are the foundational. So we have the natural sciences, the mathematics, the social science, and the humanities. So if you look at this mapping, for example, if you will talk of the subject design, now it cannot be really design if it does not incorporate engineering mechanics. If it does not incorporate mathematics that is translated into critical thinking and becomes part of the design, or mathematics directly. And then it will also include the social science issue. It will include ethical responsibilities. It will consider sustainability. It will consider the communication part. And if that's the case, then that is the proper design. Okay, another technical outcome is the technical depth. When you say technical depth, it should be supported by data, no? And the analysis of the data. It should be evaluated based on economic principles. Okay, this arrow. Now, mathematics should be involved there. Uh, that these are what we call the technical outcomes. That means if you look at the curriculum and compare it to the outcomes relationship of the American Society of Civil Engineers, then you see if you are handling engineering mechanics not just consists of statics, but when you say engineering mechanics, it includes statics, dynamics, strength of materials, and fluid mechanics. That is part of engineering mechanics. As far as the body of knowledge is concerned of the American Society of Civil Engineers. Now, our membership to the Washington Accord. Right now, there are 21 member countries in that International Engineering Alliance. So take note, this is for engineering, not for the technologist. Now, just to give you the names of the countries, Korea, Russia, Malaysia, China, South Africa, New Zealand, Australia, we have Canada, Ireland, Hong Kong, China, and Chinese Taipei. I would like also to emphasize that when you are a member of the International Engineering Alliance, there should be an organization that will represent a country. For example, Korea. Korea is represented by the Accreditation Board for Engineering Education of Korea, or we call it ABET. In Russia, it is represented by the Association for Engineering Education of Russia, and so on. In Australia, it is represented by Engineers Australia. Okay, so I hope that you will not forget that a country should be represented by an organization to represent to the International Engineering Alliance. In this case, Washington Accord, because this is for engineering. Singapore, then Sri Lanka, Japan, India, United States. In the United States, it's the ABET. No, I think this one is very familiar to, if not to all of us, to many of us, ABET. So that's the Accreditation Board for Engineering and Technology. Okay, so all in all, there are 21 member countries. What does it mean? It means to say that if you are going to enter into the alliance, it would be more difficult this time. Why? You cannot enter if the vote is not unanimous, meaning all countries should say yes, so that you can enter into this International Engineering Alliance. What is the status of the Philippines? Right now, there are what we call provisional members, or we call it the provisional signatories. Chile, Thailand, Bangladesh, Mexico, Philippines, Myanmar, and Indonesia. In the Philippines, the organization that will represent the country is the Philippine Technological Council, PTC. And again, this is accredit different universities to as to the delivery, whether it is already outcomes based or not yet, or whether the program addresses the different outcomes. Take note of that. We are in a provisional signatories. Now, actually in 2016, we had the chance of becoming a full signatory because there was a meeting in Turkey. But during that meeting, there were about 3 countries that says no, not yet. Why? Their main objection is Philippines has only 15 years of education because we haven't implemented yet during the time. It's just the implementation of the K to 12 programs. So the years of education is only 15. That is 6 elementary, 4 high school, and 5 tertiary. So we lack 1 year. Now, if we consider the current system of education for the Philippines, this is what is happening now. We start with kinder, that's 1 year. And then the elementary, 6 years. The high school, we have now 2 parts, the junior high school and the senior high school. For the senior high school, we have already the different tracking. We have the academic and we have also the technical vocational. And the academic is also divided into what we call strands. If you are an ABM, then when you proceed to college, you should enroll either accountancy, business, or management. STEM, then you can proceed to engineering. Or you can slide to technologist, no problem. If you are if you belongs to UMS in the senior high school, then your tracking should be in humanities, then and uh, UMS, humanities. I forgot the other M and the S. I think this one is about social sciences, no? Social sciences, humanities and social sciences. It should be HUMSS. Then the GAS, well, the GAS is actually for undecided. If you are not able to decide, then you follow the general academic track. Now, this one can proceed to engineering, okay, or to other to other programs in tertiary, but there will be some kind of bridging programs. Now, if you are following the technical vocational, then your tracking would be technician or technologist, no? And we have also the arts, designs, and sports. Okay, for the technician level, for the senior high school, we have 2 years. In other countries, they are making it 3 years, 3 years. I will show you an example later. In the tertiary level, we have 4 years already, no? And for the technician, it's only 2 years. But for technologist, it's also 4 years. But the difference is that there will be more industry internship for technologists compared to engineering. That is the educational system in the Philippines for engineering at the moment. If we compare it to education system in Taiwan, this is actually the presentation of Dr. Mandy Liu during the ASE 2020 International Conference. Mao ni ang sa Taiwan. Start silang elementary 6 years, and then ang ilang high school, they divide it into 3 and 3. 3 for junior high school. Unya, the remaining 3, they have to choose whether pang-academic sila or vocational. So if you choose academic, then ngari ka sa mga comprehensive universities after that. But if you choose vocational, and diri ka sa mga technical colleges, which is in their case also 4 years, no? Or you can proceed to junior college. But the junior college has the possibility to mungadto sa technical college. And then you focus more on the skills part, workforce. Mo naa ka kadaghanan sa workforce. And sa academic track, you can proceed to masteral or doctoral. So this track now will be dealing with complex engineering problems. Now, in the Philippines, we also allow crisscrossing, but there will be bridgings that we have to implement. And another, I would say, good practice also for Taiwan is this: how to become an engineer in Taiwan. Ang sa Taiwan, what happens is after you graduate, mo take kag examination. But ang ihatag nimo dili pa license, certificate pa. No, certificate pa. Meaning, once you have the certificate, capable na ka mungadtog mga company where you can be trained further. Kunya after 2 years experience, that's the time you could apply for license, no? Usa sila matawag og engineer. Where in the Philippines, lahi man ta ang ubang engineering disciplines nato, di ba? Na ay general, na ay registered, kunya nasab sila professional. Well, I'm not so sure kung asay atong i-embrace ana, whether we are contented with the current practice now, but I would like to tell you that as far as the board examination is concerned, it is not aligned to the outcomes-based education. Kaya ang outcomes-based education, we demand that our students would learn modern tools. Dili na nato makita, right? Okay, it's actually subject for discussion, and will be heavily involved in the discussion as far as that aspect is concerned. Okay, what's the role of it should be role of PICE, not PTC. Sorry, the role of PICE in the new CE program, not PTC. Role of PICE in the new CE program. Now, PICE is one of the 13 members of the Philippine Technological Council. I already mentioned earlier that the Philippine Technological Council is the umbrella organization of professional engineering societies in the Philippines. It has developed this certification and accreditation system for engineering education. And it is the sole body recognized by the Commission on Higher Education, CHED, to certify and accredit engineering programs offered by higher educational institutions, or HEI, in the country in accordance with the Washington Accord. So if your program is accredited by PTC, then most likely it is also recognized by member countries of this Washington Accord. Unya, PTC, PICE rather, is one of the 13 members. So Philippine Institute of Civil Engineers. Meaning, if a program in a university or college would seek accreditation by the PTC, unya the program is civil engineering, it is a member of PICE who will be called upon for the evaluation. So mo na atong role actually sa new program. Di gyud sila makaadtog International Engineering Alliance if the PICE will not recommend for accreditation. Ang mo accredit is the PTC, but it depends on the evaluation of a representative from PICE. Okay, personally, I have already evaluated several programs in the Philippines, but when I evaluate their programs, I will bring the name PICE. Okay, I guess this is our role, the Philippine Institute of Civil Engineers, is one of the 13 accredited professional organizations or APOS that compose the Philippine Technological Council or PTC. And as such, PICE is responsible in evaluating the civil engineering programs on their implementation of the outcomes-based education. And with that, I would like to end my presentation. Thank you for your attention.